everyone, welcome to Vedantu JEE. I'm Diksha Ma'am, your chemistry master teacher. So everybody, welcome to the class. And we already did one lecture for chemical kinetics where we learned about rate of reaction, rate of appearance, rate of disappearance. All these things we learned about right in the first lecture, right? And now there we also discuss about rate law, right? So now in that rate law, I told you that the addition of the stoichiometries in the rate law is order. And order is what we are going to learn in this throughout this video. Order, questions based on order, what all different kind of questions they can ask you, and molecularity. Right? If you are ready for that, then let me know in the chat box and let me also be ready with my your own judgment, Diksha Ma'am. Right? Diksha Ma'am is now in the study avatar. Right? Okay. So everybody, how are you all? Hi Vijay, Nitya, Veenu, Shiva, Nelo, Sanju. How are you all? Why is the class not starting? The class has started, right? Guys, what was there? No? So I had the class at 6 p.m. also, and you also had a class at 6 p.m. So I thought, why not give you a break of 30 minutes, and so that we can start a class at 8:30, so that nobody just be like, ma'am, I'm hungry, ma'am, I'm starved, ma'am, I want to eat something, I want to have dinner, right? Because now I know that you already had your dinner, right? So there is no disturbance in between, right? So I don't want the flow of the lecture to break, right? Okay, students, ma'am, voice problem. Hello. Wait a minute. Wait a minute. Let me just correct it. Okay, thank you so much, Rama Raju, right, for telling me that there was voice problem. I think the mic was not connected properly. Now I think the voice should be completely clear, right? Okay. Now is the voice completely clear to everybody? Voice clear, voice check, sound check, audio check, same thing, right? Video check, audio check, everybody. Good. Shall we start? Okay. How many of you have done the homework? Ma'am, again, you are like too much into homework and homework. Why I ask so many homework? Like, have you done it or not? Because, you know, that tells me that whether you are consistent or not, right? Whether you are also ready to put in efforts or not. Or is it just me? Because I am not going to sit in the exam. You are going to sit in the exam, right? So the homework from your side is very important, right? So let us see who has done the homework. Creative thoughts. Beta, you can also write down here your name, right? I would love to know the names of students who actually are very sincere and who do their homework, right? Then Jatin, both B and D, great. Karun, excellent. These three students have done the homework, right? Other students have not done. Very bad, right? Who promised me that they will do the homework in today's session, right? In today's session, it hardly takes 5 minutes to do the homework. Who promised me? Me. I want to spam it in the chat box that yes, I will do the homework, right? Okay. Ma'am, I don't attend the previous class. Okay, Rama Raju, now you can attend and, you know, that will be beneficial because the other sequence of the classes will be like that only. Now, let us see what was the homework. The homework was a decrease in temperature causes increase in rate of disappearance. So, when you increase the temperature, right, rate of reaction will increase in most of the cases. That means increase in rate of disappearance of reactant will be there. Decrease in no. Increase in rate of appearance, yes. Decrease in no. So answer will be both A and C is the correct answer. Absolutely right. B and D, wait a minute. They are saying decrease in temperature. My bad. They are saying that decrease in temperature. See, decrease in temperature will decrease the rate of reaction. Okay. This will decrease the rate of reaction, right? So that means product formation will be less, right? So that means decrease in rate of appearance of product and increase in the decrease in rate of appearance of product because rate of reaction has decreased, so decrease in rate of disappearance. Yes. So answer will be B and D is the correct answer here. Right? This lecture, yes, you can attend. It is not that related to your first lecture, right? But the lecture number 1 and lecture number 2 that I am taking now is directly related to rate law that we are going to do in the next classes, right? So when you come to the next class, then you have to go through lecture 1 and 2, right? Why is the negative sign added before rate of reaction in terms of disappearance of reactants? So guys, we learned that negative sign is added, reason being because rate of, because concentration change is negative, right? And rate has to be positive. To make rate positive, we put negative here, negative will be positive. That's why, because the change in concentration, because the reactant is decreasing, right? In reactant, the initial concentration is more as compared to final. That's why the concentration of reactant is negative, right? Okay. Yes, everybody. Okay, everyone. Yes. Now, let's talk about order of the reaction, right? Now, in the last lecture, I told you about rate law. That was rate is equals to, this is K, let's say this is A, let's say this is B, these are the reactants. Let's say over here you have X, over here you have Y. Then I told you in the rate law equation, this R is rate, this K is rate constant, this A, B, C, whatever you have, these are the reactants. And the addition of these stoichiometries is the order. The addition of these stoichiometries is the order of that reaction. Okay. Now let's understand order in more detail. If you see order, order is the power of sum of power of concentration terms of the reactants in the rate law expression. In the rate law expression, what is the addition of the stoichiometries, or you can say powers on the reactants? That is called on the concentration terms. What is the power? When you add them, that defines the order of that chemical reaction. Now, ma'am, order, can it be in fraction? Yes. Order can be in fraction, order can be negative, order can be positive, order can be zero, right? Order can be anything, fraction, negative, positive, zero, right? Okay. Then let's talk about, you have this rate law equation. This is the rate law equation, okay? If I see, this is called the rate law expression. Rate law expression that we have discussed in the previous class, right? Now, if you say, ma'am, what is the order with respect to A? With respect to A, you have X here, so with respect to A, order is X. With respect to B, the order is Y. The overall order of the reaction is going to be X plus Y, right? That is the overall order of that reaction. Okay, now let's talk about unit in terms of order of the reaction. Okay, how you define the units in terms of order of the reaction. So direct formula we have, that is mole per liter n-1 per second. This is the direct formula that you need to apply. Let's say, ma'am, mostly they ask about, let's say they ask you n is equals to 1, n is equals to, let's say n is equals to 0. N is the order of the reaction, right? For different reactions, N will be different. Let's say N is equals to 0, then the rate constant. You know what is rate constant? Rate constant is K. Unit of this rate constant, this is the rate constant, these units we are talking about, the units of this rate constant here, right? The unit of this rate constant is going to be, if you put N is equals to 0, that will be mole per liter. 0 minus 1 per second, answer is going to be this, that is liter per mole per second is going to be the answer. Similarly, if you put the value n is equals to 1 here, then the answer will be mole per liter 1 minus 1, that is 0. And anything raised to power 0 is equal to 1. So answer will be per second. So the unit of rate constant for n is equals to 1 is going to be per second. Similarly, you can solve for n is equals to 2, n is equals to 3, whatever they are asking you. You just need to put the value of n here and you will get the answer for units of rate constant for any of the following. Right? None is x and y are the coefficient of reactants like equilibrium constant? Not at all. Not at all. Right? So this x and y, this I have explained in the previous lecture as well. Right? This x and y may or may not. That also I'll tell you when it will be coefficient, it will not be coefficient. May or may not be stoichiometry. May or may not be stoichiometry in balanced equation. In balanced equation. That also I'll tell you when it will be stoichiometry, when it will not be stoichiometry. Okay? Yes, that we will talk about. Right? For now, just understand it may be, it may not be. You can't say it will always be, you can't say it can never be. Right? It may be, it may not be. Right? Okay? Now, if you put the n value 0, you will have the units as mole per liter per second. N is equals to 1 will be per second. N is equals to 2 will be per mole liter per second. And that's how you will get your answer. Putting the value of n, you will have the units for rate constants here. Right? Okay. Now let's see who will tell me the answer for this question here. That says, identify the order from the unit of rate constant. This is the unit of rate constant. You have to identify the order. Right? See, simple thing is just compare it with this thing. You have mole per liter per second. This is 1 minus n. I think I have written n minus 1 here. It should be 1 minus n. Okay, it should not be n minus 1. It should be 1 minus n. My bad. It should be 1 minus n. Okay. It should be 1 minus n. Okay. Mole per liter unit of rate constant will be wait a minute. Put n is equals to 0. No, it will be that only. N minus 1. Okay, chalo. Let's do this here. Let's do this here. Now, if you talk about per second, if you want to have only per second here, n value should be equals to 0. That means this should be a 0 order reaction. Okay. If you want to have liter per mole per second, that means per liter has to be equal to liter per mole. Right? Okay. If you want to put in the value of liter per mole here, can I write it as liter per mole 1 minus n. Okay? You can put in the value liter per mole 1 minus n. Now 1 minus n is equals to minus 1. Then n is going to be minus 1. This you can put n here. N can come here. N is equals to 2. So that means order of the reaction has to be 2 here. It should be a second order reaction. Right? If it is a second order reaction, you can see the answer will be liter per mole per second. That will be the correct answer. Liter per mole per second. Okay. You just have to compare that the normal units are mole per liter, n minus 1 per second. You can do it in this way also, that here it is mole per liter converted into mole per liter. So it will be mole per liter minus 1 per second. That is the same thing. So when you compare this, n minus 1 will be equals to minus 1. So it will be equals to n minus 1 is equals to minus 1. So that will be equals to n is equals to wait a minute. Mole. This is per liter. Per it is this. Wait a minute. What we are doing wrong? mole per liter n minus 1 only it should be. Mole per liter minus 1 here. Minus 1 is same thing, right? This is per liter here. That is per liter. So n minus 1 is equals to minus 1. Achha, n1 minus 1 is equals to 1 or minus 1. So it has to be equals to 0, but that is not true. Some gadbad we are doing here. Earlier, we were able to solve this. Okay? Wait a minute. If I compare this with, if I complete, this is liter per mole. Okay? This is liter per mole per second. This is, if I do the opposite of this will be liter per mole. This will be 1 minus n per second. So 1 minus n has to be equals to 1. So n should be equals to, if you take n here, this will be equals to 1 minus 1, that is 0, but that is not true. Wait a minute. Because something is not right here, right? Let me just, just give me a second. Something is not right here. Just give me a second. Maybe the question is wrong. Wait a minute. This is what I was thinking now. Yes, yes, it is written wrong here. I have to make it correct. Let me just reintroduce this to you. Right, wait a minute, because this is coming out to be wrong here, right? So I'll just rewrite this thing, right? Wait a minute. This has to be mole. Okay, let's just reintroduce this to you. If you talk about the rate law expression, this is x plus y, that is the order of the reaction. Now, we will talk about rate constant in terms of order of the reaction, and that will be equals to mole per liter 1 minus n per second, right? So here n can be equals to 0, 1, 2, 3 and so on, whatever, right? If I put n is equals to 0 or I put n is equals to 1 or I put n is equals to 2, the values will be different, right? So if I put n is equals to 0 here, then the answer will be mole per liter per second, because you are putting n is equals to 0 here, right? If I put n is equals to 1 here, then the answer will be mole per liter. 1 minus 1 is 0 and this is per second, so answer is going to be per second. That is for n is equals to 1. For n is equals to 2, it is mole per liter. This is 1 minus 2 per second and answer is going to be minus 1 here. So it will be opposite. So it will be liter per mole per second, and that's how you will get your answer here, right? Okay. Okay, students, everybody. And then the answer is going to be mole per liter per second for your zero order, for first order and for second order. And here please correct it, right? Here it should be mole per liter, right? It should be mole per liter 1 minus n per second. Okay, that is going to be the answer here, right? Okay, now we will solve these questions here. First question is K is equals to per second. This is liter per mole. Now, if you see this, K is nothing but mole per liter. This is 1 minus n per second. So, once you put the value, see, if you just need to have per second, that means this 1 minus n has to be equals to 0. That is only 0 if n is equals to 1. So, that is going to be a first order reaction. Okay. If you see this here, mole per liter, if I convert this, it is nothing but it is mole per liter minus 1 per second. That means n, that means 1 minus n is equals to minus 1. So n should be equals to 2 here. So answer will be, it is a second order reaction. Okay. Third is mole per liter per second. That also we have to see what is the answer here, right? Per mole per liter is a little weird combination here, but still let's see that. If this is mole, if I convert it into mole per liter will not be possible here in this case. Per second is same in only in all the cases. We can say it is mole liter minus 1. We can't compare it like that, right? So it is nothing but it is basically something like this. I think this is the wrong thing is given here, right? It should be mole and it should be liter here, okay? Because corresponding to that, we don't have any as such units, right? So it should be mole liter per second. If you compare this, mole per mole liter, this is per mole liter per second, again the same thing. Or I would just change the units to this thing. Now you tell me what is the answer for this one. Now you tell me what is the answer for this one. It is mole per liter per second. Mole per liter is this. So mole per liter is 1. So it will be 1 minus n is equals to 1. So n has to be equals to 1 minus 1. That is n is equals to 0. So this will become a zero order reaction. And that's how from the units you can predict that which kind of reaction this is. Is this a first order? Because we are going to study zero order, first order, second order reaction in detail. And in those reactions also you will study that basically how like you can calculate time, half-life period. For that you should know what kind of reaction it is. Because zero order, first order, second order, they have different formulas. And in that this will help you. For example, rate constant is given to you. So you can predict that this is a first order reaction, this is a second order reaction, which formulas you have to use. Okay, right? Ma'am, why constant units are changes that give some reactions? See, why units are changing, the reason is here. Why unit is changing? If you see the rate law expression, this x and y is changing, no? In first order reaction, x and y is different. Second order reaction, x and y is different. And what is this rate constant? Rate constant is rate divided by concentration raised to power order, right? So that's why you have these units. Achha, if you ask me, ma'am, why we have these units? If you see, K is equals to rate divided by concentration raised to power n, right? Okay, because it is here concentration raised to power n. So we can also write what is the rate basically. Rate is going to be nothing but mole per liter and you have per second. That is the rate. Why it is so? Because it is concentration divided by time. And what is this? Concentration is also mole per liter and this is n. That's why it becomes mole per liter 1 minus n per second. Okay? So that's how you have this formula. That's why we have a general formula, because n is changing. That's why rate constant units are also going to change. Okay, is that clear? Right, everybody? Is that clear? Is that clear to everybody or not? Hanji, that is clear na? Rate constant units. Now if you see this, the rate constant of a reaction is equal to rate of reaction. Rate constant of, they are saying that rate constant of a reaction is equals to rate of a reaction. So this is rate of a reaction, this is rate constant. That will be equal because this is concentration, this is order. Either order should be equals to 0 or concentration should be equals to unity. Right? Either of these two things should be there or both should be there if you want to make R is equals to K. Right? So when concentration do not change with time, nothing like that. When concentration change with time, there is no, at time 0, when concentration of all the reactants are unity, this is the correct answer. It changes, it does not change, there is no link here, right? The link is that concentration should be 1 or the order should be unity. Then we can say that rate constant will be equals to the rate of reaction, right? Okay. Right, everybody? Shlok, for now, for you, stoichiometry means whenever, let's say, this reaction is given, AABB, and this give rise to CC. This small a, small b, small c, these are the stoichiometries. For example, they have given you H2 plus half O2 give rise to H2. Now this one, this half, and this one, this is stoichiometry. In detail stoichiometry, I am teaching you in some basic concepts of chemistry at 6 p.m. You can watch that lecture. But for now, you can just understand the digit, that is before the compound, that is called the stoichiometry. Right? Okay? Okay, everybody? Understood? Okay, Ji. Chal. Now, let's see this. Now, let's see some properties of order of reaction. Order is experimentally derived. We are saying order is experimentally derived. That means if this is the reaction, if you see order is dependent, see rate of reaction, we calculate this in terms of reactants. Okay. So, rate will be equals to K. This is N2O raised to power 2. Is it? No. If you see, expected order is 2, but in reality, order is 1. That's why it is derived experimentally, right? It is not derived. You can't just see the reaction and tell that the order is 2, 1 or something. No, right? So here, order is derived experimentally. It has no relation with the reaction that you have, right? Okay, so that's why, therefore, the rate of reaction is this. Ma'am, how can you say this is 1? So basically what happens, this order is defined in the slowest step. In the slowest step. I'll tell you why. Okay. If you see this reaction also, same thing. Here you were expecting that it should be NH3 raised to power 2. Because in the stoichiometry it is 2. But I told you it may or may not be equal to stoichiometry. So that's why the expected order is 2, but in reality the order is 0. That means it is equals to R is equals to K. Now you will ask me, ma'am, why? Ma'am, you have written a thing that order of reaction may or may not be equal to stoichiometry. What is the reason? How can you just say it may or may not be equal to stoichiometry? See, for that you have to understand two things. That is type of reaction. Okay, that is type of reaction. One reaction is a complex, or you can say first reaction is elementary, and the other one is the complex reaction. Understood? Elementary reaction occurs only in one step, right? But in complex reaction, you have multiple steps. Here, because it is just one step, so that step is only the R rate determining step. Here, that step is RDS, that is your rate determining step. But in complex reaction, the slowest step is rate determining step, that you will learn in organic chemistry also, right? The slowest step is your rate determining step. Okay, right? Understood? What happened? Okay, ABC, I forgive you. Please now focus in the class. Please. Okay, I forgive you. Now please focus in the class. Okay? ठीक है जी? Now please everyone be sincere. Right? Done. Okay? It's okay, ABC, it's totally fine. If you're genuine, then it's totally fine, right? It's good that you are feeling bad for what you did, but it's okay, right? Now you can just focus in the class, right? Good. Now, Students, we have two types of reactions. Now we are asking why it is so, right? Students, you are also asking me, ma'am, why it is so, ma'am? Why the stoichiometry and order is different, ma'am? How can you say that? Because I am saying that order depends on the slowest step. You have two types of reactions. One is elementary, one is complex. In elementary, you have only one step. Let's say we talk about an elementary reaction in which you have 3 of A plus 2 of B give rise to 3 of C plus 4 of D. Now you have to tell me what is the rate law. What is the rate law? Because in the elementary step, that is only the rate determining step. So in this case, the rate law, we can easily define that R is equals to K, reactant is A, reactant is B, and it will be the raised to power the stoichiometry only. Raised to power A is 3, B is 2. Because in elementary step, that step is only the rate determining step. Right? Okay. Yes, everybody. Okay. Shlok, I have told you stoichiometry is this thing. This is stoichiometry. In a balanced chemical equation, this digit that is written after balanced equation, that is stoichiometry. Okay? That is stoichiometry. Okay? Yes, everybody. Tell me if that is clear. In an elementary step, it is a single step. It is just one step reaction. That's why in these kind of reactions, right, you have which thing? In elementary step, the stoichiometry is the order. So order with respect to A, order with respect to A is going to be 3. Order with respect to B is going to be 2. Is that clear? Is that clear to everybody here? Now, if you talk about a complex reaction, this may be multiple step. This is multiple step. Now, for example, they have given you this reaction that 2A plus 3C give rise to 4B, 2A plus 3B give rise to 4C plus 2D. This is given to you, right? But they are saying that this is a complex reaction. And the slowest step, they are saying that the slowest step is A plus A give rise to the slowest step is A plus 2B give rise to AB2. This is the slowest step that is given to. Okay? Now tell me what is the rate law. What is the rate law? I am writing two things here. You need to tell me which is correct. Should it be 2 and 3 or should it be 1 and 2? Which is the correct answer here of the rate law? Everybody, which is the correct answer of here for the rate law? Now, what I defined that whenever you have a complex reaction, it doesn't matter what is the exact reaction. What is the overall reaction? It doesn't matter. It depends upon the slowest step. So in the slowest step, in A, you have power 1 and in B, you have power 2. So that's why this is the incorrect one. This is the correct one. Okay. Is that clear, students? Option 2. Right? Why it is so? That is clear to everybody, right? Okay. Now, one student asked me, ma'am, why concentration changes? Because reaction happens, that's why concentration changes. Right? Okay. Chal. Now, let's see the questions here. If the concentration of the reactant in the elementary reaction, which if elementary reaction is given to you, will the stoichiometry will be the order or not? If this is an elementary reaction they have given you, in that case, rate will be equals to A raised to power 1, B raised to power 2. Is it the correct answer when I write, ma'am? Why is the concentration units changed, ma'am? Beta, concentration units when they are changing, tell me when they are changing. Okay. Tell me where concentration units are changing. Where you can see concentration units are mole per liter only. I have even derived it for you. Rate is concentration by time, and this is concentration raised per n, concentration mole per liter. I am writing the units of concentration as mole per liter only. Order is changing. That's why concentration is concentration units are not changing. Order is changing. Okay. Clear? ठीक है जी? Clear? Clear na? Concentration units are nowhere changing. Right? Okay. So if the concentration of the reactant in the elementary reaction is this, is increased 3 folds. Now he is saying the concentration is increased 3 folds. That means A is also 3 of A. All the reactants are 3 times. So this is also 3 of A. This is 3 of B square. So here answer will be K. This is nothing but 3 of A. This is 339 of B square. So it is going to be K. This will be 3, 9, 9, 9 to 27. This will be K, A, B square. What is this K, A, B square? That is nothing but R. So it has to be R dash is equals to 27 into R. That is going to be the correct answer here. Right? That is going to be the correct answer here. If that is clear to everybody, then let me know. Answer is going to be A is the correct answer here. Right? Next question is, you have the reaction in which reactant changes into products. Reactant is changing into products. Follows second order kinetics. That means rate of the reaction is K. This is reactant raised to power 2. They are telling that it is a second order kinetics. That means N is equals to 2 here. Right? That means this has to be the rate law. If concentration R is increased, now we are saying that the concentration R is increased 4 times. R is increased 4 times. 4 of R and whole square. That is R dash is nothing but 16K R square. That means R dash is equals to 16 into R. So can I see it is 16 times here. So answer is going to be C is the correct answer here. Is that clear to everybody? Right? Beta, nuclear reaction is altogether a different thing. Okay? Nuclear reaction so don't even follow law of conservation of mass. Right? Okay? Next is if they have now these kind of questions are kind of famous, right? So if they have given you questions in which they have like they have changed the they have given you in the tabular form. Now what you have to do? Okay? For this, let's see, you have to remember one thing, that is a trick. Okay, ji? That is a trick. So remember one thing, beta. Remember one thing, that R is equals to R dash is equals to X raised to power N of R. Okay. New rate is equals to X raised to power N of old rate. What is X? X is nothing but, is the concentration doubled? Concentration doubled or tripled or what? How many times the concentration increases or decreases? You can say how many times concentration increases or decreases. Okay, that you can write here. What is N? N is going to be the order of reaction. N is going to be the order of the reaction. Now see this thing here. Now we are going to see this question. Okay, let's do one question here, right? Let's say I am saying that there is some reaction R is equals to K, A raised to power X, B raised to power Y. Okay. Now, these kind of questions also they ask you. Before tabular question, I am giving you this example. Okay. Let's say they are saying that if A is doubled, rate is 4 times, rate increases 4 times. If B is doubled, rate is same. Now tell me what is the order of that reaction, right? Okay, now they're asking you what is these kind of questions you will see. I'll tell you how simply you can do this, right? Very simply you can solve these kind of questions, okay? Very simply, you will find it very, very simple. This is the question that is given to you, right? Now let us see how to answer this question, right? See, if you talk about A, in case of A, you will write with respect to A. With respect to A, what is happening? You will write it here. With respect to A, what is happening? With respect to A, if concentration is double, that means X is equals to 2. 2 times it is increasing. And this R is increasing 4 times. That means this X raised to power N is equals to 4. That means here order should be what? X raised to power N is 4 means 2 raised to power N should be equals to 4. It means N should be equals to 2. That means order with respect to A is 2. So we can say rate is equals to K, A raised to power 2. Now for B you have to answer. Okay? Now for B you have to answer. Right? Now for B what you have to answer here. If you see this, I'll just write it here. Right? Okay. We can just write with respect to B. X is what, beta? X is 2 times. The concentration is doubled. X is 2 times. Rate is same, that means X raised to power N is equals to 1. It is not increasing, it is not decreasing, it is 1. Right? So we can say 2 raised to power N is equals to 1. That means N should be equals to 0. That means N should be equals to 0 with respect to B. So this will be the order of the reaction. Is that clear to everybody or not? Right? So beta, this is the trick, right? That I don't know if you will see this in any book or not, because this, so by doing the questions I made it myself only, right? So X raised to power N, right? X is what? X is how many times concentration is increased or decreased. N is the order of the reaction. And X raised to power N is the how many times rate increases or decreases. Okay? By this, you will answer this question. Is that clear to everybody? If you are clear on this part, then I'll start with this question here. That is the same thing in the form of table. Same kind of thing in the form of table we have. Okay? Same kind of thing we have in the form of table. So there are different methods in books. Usually you will see, you will have to equate, then do calculations and all that. We are not going to do. Right? We are going to solve this very simply. Firstly, you will see concentration of A, keep it constant. A is constant here and here. Keep A constant. Okay? If A is constant, then this is 0.2, this is 0.4, this is multiplied by 2, this is concentration of B is increasing 2 times. Rate is increasing how many times? 7, 4. Right? Rate is increasing 4 times. 7, 4, 28. Right? Is that clear to everybody? Firstly, keep this constant. Keep any of the concentration constant. Now we are finding it with respect to B. With respect to B. With respect to B, keeping a constant, keeping a constant, keeping a constant. What you have, concentration is doubling. That means x is equals to 2 times, right? X is equals to 2 times in this case. What is the value of x raised to power n? How many times rate is increasing? That is 4 times. So you can just write it here. X raised to power n is equals to 4 times. If you put in the value, that will be 2 raised to power n is equals to 4 times. So can I say, if you put this value, 2 raised to power n is equals to 4. So n should be equals to 2. So order with respect to B is equals to 2. Right? Everybody, if that is clear, then let me know in the chat box. Directly you can solve it this way. Okay, directly you can solve it this way. That will be like helpful for you in the exam. Okay? Okay? Okay, Ji. Next is, now tell me where B is constant. Can you see anywhere where B is constant? Where B is constant? This is 0.1, this is 0.1, this is where B is constant. And here concentration of A is increasing 4 times. And the rate increasing how many times? 6 into 4 only, right? It is also increasing 4 times. So now, can I say with respect to B, keeping a constant, wait a minute, with respect to A we are finding out, keeping B constant, है ना? We are keeping B as constant, keeping B constant, B constant. What you will see, what is the value of X here? Who will tell me what is the value of X? What is the value of X raised to power n? What is the value of X? What is the value of A with respect to A is 1? Okay, Gokul. Come and meet you. Thank you for efforts. Thank you, ABC. Thank you so much. Order of the A is 1. Right? So if you see this here, X is nothing but X is 4. X raised to power n is rate, that is also 4. So I can just write it here. With respect to B, X is 4, X raised to power n is also 4. So you can write 4 raised to power n is equals to 4. That is only possible if n is equals to 1. So we can say order with respect to A is equals to 1. So the rate law will be R is equals to K, A raised to power 1, B raised to power 2. That will be the rate law of this equation, right? Overall order will be total order of a reaction. Order of reaction is going to be 3. Okay? Yes, everybody. How many of you find this easy? How many of you are finding this easy, beta? Let me know. How many of you are finding this easy? Right? We have one more question related to that. I want you to solve every kind of question possible so that you get full marks here. Right? Because it is actually a very scoring chapter. Okay. So for a chemical reaction, A plus B give rise to product. The order is 1 with respect to A and B. So they are saying that R is equals to K. You have A and B, and they are saying it is 1 with respect to A and B. With 1 also, with A also it is 1, B also it is 1. Right? That means the overall order of this reaction is 2. Now this chart is given you. So they are saying that you have to find the value of X and Y. Okay? Cool. So, okay. So this is So what we can do here, if this is constant, right? This is constant. See how we will find it, okay? This is constant, that means B is constant. B is constant. We don't know how much times A is increasing. but rate is increasing 4 times. Can you see rate is increasing 4 times? Rate is increasing 4 times. Rate is increasing 4 times multiplied by 4. Now this is constant. This is increasing 4 times due to which? Because if this also increases 4 times, if this also increases 4 times, then if this is constant, then the rate can increase 4 times. So can I say that x will be equals to, it will increase 4 times, 4 to 8. So answer is going to be 80 here. X is equals to 80. Is that clear? Okay, students? Right? Right? Most welcome, Gokul. Okay, let me know if that is clear. Right? Now, I'll again make the same thing. Right? You have the same thing here. R is equals to K, A raised to power 1, B raised to power 1. Right? Now, what we are saying that this is where you have to find Y. We are saying that E is multiplied by 2. A is increasing 2 times. A is increasing 2 times. Okay. R is increasing how many times? R is increasing 8 times here. So can I just write it as 8R? Then what is the value of B? This is 2, this is 8. 8 is equals to 2 into, this is some Y amount it is increasing. I don't know what amount. Not even small y I am writing, just randomly you can also write y. Right? If I multiply this by 4, then it will become 8. So if I multiply this by 4, then 4 into 2 will become 8. So can I say this is also increasing 4 times? That means 0.5 into 4, that is 2. So y is going to be 2. Is that clear, everybody? Is that clear, everybody? Yes, bachcho, is that clear? Hanji. Any problem here? Any problem? This is actually very, very important questions that I am teaching you based on table, based on order, how to find the order, different ways they can ask you. I am not repeating the same kind of question. First, I asked you double and triple. Then I gave you table. Then I am asking you to find x and y value. So no question is a repeated question here. Right? Okay. Class 11 having a test on it. Vijay, I will teach that, but that is after some basic concepts of chemistry. Right? I have to follow the sequence. Right? Okay. So, answer will be 80 and 2. Answer is A is the correct answer. Okay. Yes, everybody. Now, next question is, the reaction is this some reaction is given to you and they are saying this is an elementary reaction. So whenever they say that it's an elementary reaction, you write K is equals to, R is equals to K, A raised to power, this is 2, so you'll write 2 here. This is B2, so you'll write B2 raised to power 1, because you have to write the stoichiometry. Here stoichiometry is 2, here stoichiometry is 1. Why I am writing order in the terms of stoichiometry? Reason is because it is a elementary reaction. Right? Okay? Right, everybody? Now, for a certain quantity of reactant, they are saying there is certain quantity of reactant. If the volume of the reactant vessel, very important, vessel is reduced by a factor of 3. Volume is reduced by 1 by 3. Rate of the reaction increases by which factor? See, volume and concentration are inversely proportional. When you add water, right, when you dilute something, concentration decreases. If the volume is decreasing, concentration will increase by 3 times. Okay, if the volume is reduced by 3 times, then the concentration will increase, because concentration and volume are inversely proportional. Right? Okay. Concentration is, Now, if for a certain quantity of reactants, if the volume of the reaction is reduced by this, the rate of the reaction increases by which factor? The simple thing is, this is also increased by 3 times. Both are increased by 3 times. So this will be 3 of A square. This is increased by 3 times, 3 of B2, right? Raised to power 1. So this will be 339, 92, 27, 27K A square B2 1. So it will be 21. Sorry, 27. So answer is going to be 27. Okay, everyone? Yes, everybody? Okay, everyone? Hanji. Next question, let us see. Next is order of a complex reaction. Till now, we have done simple chemical, like elementary reactions. Tabular form we did, increasing, decreasing we did. Now we are going to move towards complex reactions, how the questions are asked in complex reactions, okay? So a reaction that take multiple steps to form final product. Multiple steps it is taking. The slowest step of a complex reaction is called rate determining step, right? Now, let's see, this is your JEE Mains 2025 previous year question. The focus has now turned, wait a minute guys, just give me a second. Oof. I would have died if I don't see that what is going on actually in the studio. Oh my God. Electricity and water, dangerous combination. Huh? Order of the complex reaction. See, now this is a very, very important question. 3 kind of questions I have picked out here. Okay? If till now you were finding the questions difficult, this is the most difficult question of chemical kinetics altogether. Right? Okay? That's why there is a separate lecture for order of reaction. But it's not that difficult if you practice. That's why I have taken 3 questions. In first step, you might find it difficult. Second question will be easy. Third will be even more easier. Okay, let's do this. So this is the reaction. They have given that this is a complex reaction. Okay, that means rate law, you can't write it based on this reaction. You will see the slowest step here. So based on slowest step, the rate will be equals to K. This is reactant. Reactant is here A and here reactant is B2. Okay? Both are raised to power 1 and 1. Clear? First thing is I will write the rate law expression. This is it's not a difficult task to find out that this is this kind of question. Okay? First thing that you will do is you will write the value of rate law expression in terms of the slowest step. Reactant is A and B2, you will write A and B2 raised to power the stoichiometry. Okay? Now, second step. You will see that, ma'am, in the overall reaction, we don't have A. We have A, B2, but we don't have A. And understand one thing. In the rate law expression, the terms that you are writing here should be in the overall reaction on the reactant side. This means this A, this B, this A, all are intermediates. In the overall reaction, you have the reactants. Otherwise, all other terms here are intermediates. This AB is the intermediate. This B is intermediate. This AB is intermediate. This A, B, all these are intermediates. This A2 and this B2 and this, AB is also not intermediate. AB is not an intermediate. Okay? These are not intermediate. Otherwise, all these are the intermediates only. What are intermediates? This is intermediate, 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 this is intermediate. And intermediate should not be there in the rate law expression. It can never be there, right? So now that means, now just put it 1 here. That means that you have to eliminate the Eliminate A here. How you will eliminate? Now you will see that other two are the fast step. This is the fast step, this is the fast step. You will see the one step that is in equilibrium, right? So this step is in equilibrium. You will see this step, right? Now from this equation you have K equilibrium is equals to reactant by product. Reactant is A2, product is A square. Or you can also write it this way. Two ways of writing. You can choose any of the ways. Or you can say that K1 is equals to K1 multiplied by A2 and here K2 multiplied by A square. Because this equilibrium constant multiplied by the reactant, this equilibrium constant, K1 is the equilibrium constant multiplied by the reactant, K2 equilibrium constant multiplied by the reactant of K2, that is A square. How many of you are able to understand these 2 points? How many of you are able to understand these points? I think 2 more lectures of chemical kinetics. 2 more lectures or maximum 3. Okay? The order of the overall reaction is 1.5. That's great. Very good. Yes, that will come out to be 1.5 only. Right? That is clear to everybody? Yes. Now, you have to replace the value of A from here. So, A is nothing that is equals to K1 by K2. This is A2 and take the under root of overall. That will be the value of A. Put it here. Put it here. Put the value of A here. Your answer will be R is equals to K. This is A is what? A is K1 by K2. So you can put it as K1 by K2 under root. Then you can put it as under root of A2. A2 also under root of A2. And this is B2. B2 you have written here at only. I have just replaced the value of A to this. I have just substituted the value of A. Right? Now, this whole thing is a rate constant only. So, you can say K. This is A2, 1. This is B2. Now, this is your final answer where you have written the rate law expression in the terms of the terms that are mentioned in the overall reaction. Okay? Okay, ji? But I will not repeat the same question. Rather, I have 2 more examples. So, I will repeat the examples. Okay. So, here the answer will become 1 by 2. So, with respect to A, answer is half. With respect to B, answer is 1. Overall order is 1 plus half, that is 1.5. Okay. That becomes the correct answer. Okay. Now, those who were not able to understand the first question, please pay attention here. Okay. Please pay attention here. Those who were able to understand, try to solve it yourself. Okay, ji? Beta, what is the first step? What is the first step? Everybody, first step is you should know that this is a complex reaction. In a complex reaction, you will firstly see the slowest step. Write the rate law according to the slowest step. R is equals to K. This is oxygen raised to power 1. This is O3 raised to power 1. Okay, ji? Now, mark it 1. Now, see, in the overall reaction, you have O3, you have O2. But you don't, see, in the reactant side, you only have O3. You don't have O here. That means you have to replace it in the form of O. Right? Okay, you have to replace it in the form of O. How do you replace it? Right? So, this is your equilibrium. Now, from the equilibrium equation, what you will see, let's say this is K1. I am assuming this is K1, this is K2. This is what I am assuming, right? K1 into reactant is O3. equals to K2 into reactant side. This is, if you see, no. If I see this is K2, this is K1, its reactant is this. K1 reactant is O2 and oxygen. Reactant of K2 is O3, right? Okay. Now, this is the equation that we draw from the equilibrium equation, right? Okay. Now, what we have to replace? We have to replace oxygen here. So, oxygen is equals to K2 by K1. This is O3 divided by O2. I'll just replace this thing as it is here. Okay, so as it is, I'll write it here. R is equals to K. Oxygen is nothing but it is K2 by K1, right? Then it is O3 divided by O2. This is O3. Now, if you see this here, this overall is nothing but this is another constant. You can say it as K3, whatever you want to write it, right? So, this will be O3, 1 plus 1 is 2, and this will be O2 minus 1. Now, can you see in the final answer, you have O3 and O2, and O3 and O2 both are in the final overall reaction, right? So, can I say that here, with respect to O3, it is 2. With respect to O2, it is minus 1. Overall, it is 2 minus 1, that is 1. Is that clear to everybody or not? Yes. Yes, student, is that clear to everyone or not? What we are doing here? Firstly, we will see in the slowest step what is the reaction. Now we will see what we have to replace. Which thing is not there in the overall reaction? That is oxygen. So oxygen we will replace from the equation that is there in the equilibrium. So this is in the equilibrium. You can put directly also, you can say K equilibrium is equals to product by reactant. So you can write that O2 by O, है ना? This is product now, O2 multiplied by oxygen by O3. This also you can directly write, but I prefer writing it this way, that this is K1. K1, the reactant is O2 and oxygen. K1 multiplied by O2 and oxygen. K2, the reactant is O3. K2 multiplied by O3. You generate the value of oxygen here, put it here, you will have your answer. Okay, right? Now, we are going to see one more question based on the same concept. Okay, why so many questions based on same concept? Because this is where students get stuck and I don't want you to get stuck here, right? Okay. Ma'am, can concentration of product also in the rate law? Concentration of product, Gokul, I didn't get you. What you are saying? Can you please elaborate? Yes, can you please elaborate that thing? Chal. Now, if you see this here, students, the reaction that is this takes place through the mechanism given below. Now, what is the slowest step here? Slowest step is R is equals to K. This is NOBR2 and this is N. Now, can you tell me which is the value that I have to replace? In the overall reaction, you have NO, but you have Br2. You don't have NOBr2. So you have to replace NOBr2 here. NOBr2 you will replace from this side. This side NOBr2 will be equals to, you can just directly write, if this is K1, this is K2, you can just directly write K1 multiplied by NO into Br2 equals to K2 multiplied by NOBr2. So NOBr2 is equals to K1 by K2 multiplied by NO multiplied by Br2 and that's it. Okay, now you have to put this value here, put this value here, right? That is going to be R is equals to K. This is K1 by K2. This is NO. This is Br2. This is N. Right? Can you see this here? Now this overall is nothing but a new rate constant. I'll write it as K3. This is NO square. This is Br2. So can I just write it that with respect to NO, it is second order reaction. With respect to Br2, it is first order reaction. Overall, it is a third order reaction. Yes, very good. In the last example, O2 also in the rate law, but it is in the product side in the previous question, only have concentration of reactant. Gokul, yes, you can do that, right? Even it is in the product side or reactant side, it is in the product side, that's why it has -1 here, right? Okay, so even it is in the product side or reactant side, it should be in the overall reaction that is there, right? Okay. Chalo ji, that's it. Now that was about order. Now let's talk about molecularity. Okay, very small topic this is. Molecularity is the number of species that are colliding to produce the product, right? So the number of reacting species, atoms, ions, molecules taking part in an elementary reaction. In an elementary reaction, which must collide simultaneously. There should be, we will also talk about collision theory in upcoming lectures, where we will see that not only the collision, proper orientation of the collision is required here, right? So proper collision they are forming, collide simultaneously in order to bring out a chemical reaction is called molecularity of the reaction. Now molecularity cannot be zero, negative, non-integer. It can only be 1, 2, 3, right? Molecularity, zero molecules can't collide. Even 1 cannot be the molecularity. 1 molecule can't collide. Negative molecules can't collide. Half molecule cannot. You can't slice the molecule and it will collide, right? So molecule can never be non-integer, positive or negative or zero. And if you see in this elementary reaction, what is the molecularity of the above reaction? If it is an elementary reaction, molecularity is going to be equals to 2 plus 1, that is 3. In an elementary reaction, order is also 2 plus 1, that is 3. So in an elementary reaction, order is equals to molecularity. Okay, ji? Because order you can determine only for elementary reaction from the reaction, right? So that's why we are able to define molecularity. You can define anywhere that what is the reactants, how many molecules are colliding, that will be the molecularity, right? Okay, so for an elementary reaction, molecularity is equals to order. That is a very important thing. Reactions having molecularity 3 or more are very rare or slow to proceed. Why? Because of resistance. See, molecules are big. If you say 3 molecules colliding with proper orientation, it's very very difficult. And 4 molecules colliding together is impossible. So that's why reactions having molecularity 3 or more are very rare. Because the proper orientation is not fine, proper collision is not fine. Right? Now let's talk about order and molecularity difference, very important, right? Statement based questions can be asked. Firstly, order is experimental quantity, right? And it can be 0, negative, positive or in fraction. And molecularity can never be 0, negative or in fraction. Order is applicable to both elementary and complex reaction, but molecularity is applicable only for elementary reaction. It has no meaning for the complex reaction. Only for elementary reactions we define the molecularity. RDS determines or order of a reaction in the complex, and here in the complex reaction nothing is there. Molecularity of slowest step is same as the order of the overall reaction. Okay, that means molecularity of the slowest step is equals to the order of the overall reaction. Okay, and understand one thing. If you have this thing, that is rate is equals to K, A raised to power 1, B raised to power 1 by 2, they are saying, can this reaction be elementary? Now, if reaction has to be elementary, order should be equal to molecularity. Understood? Now, because they are saying it is an elementary reaction, right? That means order should be equals to, order will be equals to 1 plus 1 by 2, that is 1.5. Now, tell me one thing. Molecularity can never be fraction. That means here molecularity is not equal to order. So that's why, because here molecularity is not equals to order, so that's why it is not an elementary reaction. Not an elementary reaction. Okay? Molecularity can never be in the fraction. Okay? Last question I think of today, that is last second question I think. Classify the following as unimolecular or bimolecular reaction. So see, this molecule is just 1, so it is unimolecular. Here it is 2, so it is bimolecular. It is 2, it is bimolecular. It is 2, it is bimolecular. Right? Okay. Now, in detail now, we will learn about unimolecular and bimolecular reaction. That is SN1 and SN2 reaction. This is unimolecular reaction. This is bimolecular reaction. We will learn this in organic chemistry. Your first chapter of organic chemistry of class 12, haloalkanes, haloarenes, you will learn about SN1, SN2. That is related to this thing, right? We will learn about that thing there, right? Next is the molecularity of the above reaction is. Now they are saying the molecularity of above reaction is 2 plus 3 plus C2 give rise to D, right? The above reaction, the molecularity will be 3, 4, 5. See, molecularity cannot be beyond that, right? So molecularity can never be 5, it cannot be 3, molecularity cannot be 1, so molecularity will be 2. You might end up doing mistake here, right? You will say, ma'am, 2 plus 3, 4, 5, 6. It's not 6. Molecularity will not be 1, it's not possible. Molecularity cannot be 3, it's very difficult. 5, so it's not possible at all. So only option we are left with is 2 is the correct answer. Is that clear to everybody? Okay. Now you have your homework questions here. Which of the following can be order of the reaction? You need to define based on the rules of order of reaction. Order can be 0, negative, it can be in fraction. You have to answer this, right? This is 5 factorial. You are like mathematics student, so you already know what is factorial, right? So next is molecularity of reaction is equal to order of the reaction in case of RDS, elementary, each step, complex, none of the above. So this is the second question that you have, right? Okay. And that's it for today, students. That's it for today. Now, I want you guys to do your homework in the comment section. I am waiting for your homework. If you don't do the homework, I can see your sincerity by that only, right? So I don't want to see that you guys not doing your homework. That will be not at all good, right? And students, if you can see here, right? If you can see here in the comment section, we have Sigma JEE batch of 2026 students. You're in class 12 now, and this batch is specially designed for class 12 and droppers, right? Now you can see there are live classes, regular classes are taken in the batch, mock tests are being conducted, then modules are sent to your home. You have these kind of QR cards also available for your available for your short revision. You also have test series here in this particular lecture, in this particular batch, right? So all the things that are required are there in the batch. All you need to do is just enroll to the batch and you will be sorted, right? Okay. And for all the students who are there, for students, if you're looking for a pro course, we have pro course for 2 year as well, pro course for 1 year as well, based on like you are preparing for 26 or 27. Now in the pro course, what you have is you have dedicated, like it's like in the pro course, I am also able to see you, right? You are able to see me, that's fine, but I am also able to see you, what you are doing, your camera is on, your mic is not on the mute mode. You can anywhere, you can just ask me anywhere in the class that, ma'am, this is the doubt, please explain this, just like you ask the questions in the offline classes, right? And you have 24/7 doubt solution for you. That means whenever you are solving something, you have doubt, you just click on that video call and teacher will be available to answer your doubts, right? And other things are obviously there. Mock tests are there, test series are there, like all the modules are sent to your house, right? Hard copy modules are sent, test series hard copy are sent to your house, right? All these things are definitely there. But the best part is doubt 24/7 you can ask, and even the teacher can see how much discipline you are, have you done your homework or not. So these are the advantages of pro batch. This is for 2026 aspirant, 10,000 off is going on right now, and 2027 20,000 off is going on right now. Okay, so you can avail this opportunity as per your choice, whatever you are preparing for. Okay, yes. Okay, great. Okay, Rama, Raju, Future IITian, Vishnavi, bye bye, bye bye. Take care. See you all in the next class, right? Until then, I would love to see your comments and answers in the homework. Bye bye. Take care.